Hey 12s, today we are doing exercise 23A. So it's called regions defined by an inequality. So I'll give you a chance, copy down the notes please, and then I'll talk about it. Alrighty. Okay, so hopefully you've copied down those notes. Okay, so back in the previous years in maths, you would have remembered about number lines. So these are called inequalities. So an inequality just means instead of x equals 3, you've got a sign here greater than or equal to, and less than or equal to. So this one says x is greater than or equal to 3. So we can represent that on a number line. So there's our number line with some random numbers, goes on either way forever. And I've labelled it x, because that's the values. And it says here x is greater than or equal to 3. So there's 3, I've made a dot, and it goes that way because it's greater than 3. But you notice one thing, it's because it's equal to 3 as well, so it's a coloured in dot. If it was not equal to 3, it would be an open circle like that with an arrow. That means not equal to. So in this one would be x is greater than 3, is that one there. Excellent. Okay, so that's with just a number line. But as you can see here, when we've got an equation, we need to find a region that satisfies the inequality. So I've got some examples here. Represent each region with a suitable graph. So the first step is you've got to draw the graph first, draw the line, and then you've got to shade in which side of the graph is appropriate. And make sure you label it. So as in when you shade the region, say this is the region required. So there's no question about it. Okay, x is less than 2. Just work out where is the graph of x equals 2. Now we've done this in class. X equals 2. You find x, and there's the value of 2. And it's a vertical line. It goes like that, and it's got an arrow on either end. Okay, and it says there x is less than 2. X is equal to 2 on that line, and it's less than 2 this side of the graph. So we shade that region in, and then we should write here region required. See? And I've made one little mistake. You notice there it says x is less than. It's not equal to 2 as well. So instead of a solid line means it's equal to as well, we need to do that graph as a dotted line. So if you do it in pencil, then you can just rub it out and colour it in if you did what I did. And there's your answer, everyone. Great, let's do the next one. Y is equal to -5. So there's y, and here's the value of -5. And it's equal to as well. See how y is less than or equal to. So I know it's a solid line that goes through that point there. And it says y is less than. So where's y less than -5? Less than is down this region. So I can shade that region in. And make sure, just so there's no question about it, you write down here, region required. And we're done. Let's try the next one. X is greater than 3. So where's x equal 3? There's the value there. And it's not a solid line, so it's a dotted line. So I make that a dotted line. And it says there x is greater than 3. Where's x greater than 3? It's on this side. This side there. And you write down region required. So that means that anywhere on this side of that graph, any one of these points satisfies this equation. So later on there'll be worded questions, and then it'll make more sense. So at the moment you just need to be able to do that. Now it gets a little bit more complicated. They're special graphs, horizontal or vertical lines. Now this one, a lot of the time in real life, they're diagonal lines. So we've done this before. It says here, sketch the graph of the region, that equation. Okay, so first step is to sketch the graph. And we did this in class. There are two different methods of sketching a graph. You can either use the y-intercept and gradient method, but since it's written that way, I'm just going to use the x and y-intercept method. So if you remember that, I'm going to start off with y-intercept, let x equal 0. So I'm going to rewrite that equation, but this time x is equal to 0. So this bit becomes 0. So I've got minus 2y is less than or equal to 6. And actually, I'm just going to say it's equal to, I'm going to ignore the inequality sign until the very end, but I'll show you the last step. So now I divide both sides by -2, and I get y is equal to -3. So I'm going to write my point, 0, -3. What's the next thing we do? We go x-intercept, let y equal 0. So again, we substitute y equals 0 into that equation. We're left with 3x is equal to 6 and x is equal to 2. So they're nice integer numbers here, so they're not fractions or decimals, that's great. Okay, and that point there is the x value is 2 and the y value is 0. So we've got our two coordinates, the x and y coordinates, and now we can draw a little sketch. So remember, a sketch is not plotting points. A sketch is just a rough indication of what the graph looks like. Okay, so 2, 0 is roughly there. 0, negative 3 is down there. And now I can do my line. And you notice here, it's equal to as well. What does that mean? It means it's a solid line. It's not a dotted line. So you use your ruler, just like I am, and put an arrow on either side. And that's the first part of the problem done. So we've done our equation of a line, but now we need to know which side of our graph is the region required. Is it this side above here, or is it below there? Now, this is the important bit. What we need to do is called a test point. So I'm going to say a test point. Now what you need to do is pick any point that's not on the line, and we're going to substitute both coordinates into this equation. So the easiest point to pick is the origin. So this is my test point here, test point, and it's 0, 0. So my test point is 0, 0. So I'm going to write here test point 0, 0 so the teacher knows what I'm doing if it was an exam. So I'm going to substitute x equals 0 and y equals 0 into this equation. So we get 3 lots of 0 is 0, minus 2 lots of 0 is 0, so it's a nice easy sum. So we get 0 is less than or equal to 6. Now the last step to analyse is this true? Is 0 less than or equal to 6? Yes, 0 is less than 6, isn't it? That is true. So because it's true, that means this point, 0, 0, is in the region required. So what we do here is we say this region above the line here that involves that point, 0, 0, is in that region required. So we write down here, region required. So just to clarify, a lot of people have a bit of confusion around this. If I substituted this in and this was a false statement, this was not true, then that point there, 0, 0, is not in the region required, and therefore you'd shade the other region and say this region's the region required. Hopefully that makes sense. So what you could do is pick any point you want. I could pick the point here, 1, 7 if I wanted to, but then the maths is a little bit harder. So 0, 0 is always a great point to choose as a test point, unless of course the graph goes through that point, and then you don't want to do that. You have to pick any other point. So I could have picked a point, just say down here somewhere. If I pick the coordinates here, I substitute the values in, and I would have got something like, just say I picked a point here, for instance, 5 and minus 5. So just say I picked that point there. I substitute the values in, I'm making this up, but I might have got something like 12 is less than or equal to 6. That's what when I substitute the values of that point into my equation. Is 12 less than or equal to 6? No, it's not. That's not true. So therefore, this point is not in the region required, and then you'd shade the other side of that graph, because this is the region required. So hopefully that makes sense, everybody. So make sure you do 23A, and I'll get a couple of other videos up shortly, and I'll see you soon. Bye.